With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello student, today I am solving the question. The question is explain alpha-Halocarbonyl compound even the 3-degree types do not undergoes SN1 reaction. Which is more react and question B is which is more reactive, propyl chloride or this compound with NAI acetone? And third C question is acetal and ketal are regenerated back to carbonyl compound with H3O plus but not with OH minus. D is cyclohexane is more reactive than cyclopentanone with HCl. So let's solve first A question. A is as we know that when in SN1 reaction what will happen, so suppose here have one carbon and attached with this like suppose this compound and this chlorine remove and work as a leaving group and formation of a tertiary carbocation takes place. Okay, so same goes to this compound also. So let's understand how it will go. So our compound is this RCr. Here is chlorine and here is aldehyde group. Okay, same goes to this F. So formation of this is leaving group, it remove and when formation of carbocation takes place like this. Okay, this is also tertiary carbocation. So because of this tertiary carbocation it one reaction. Okay, but this is not stable. Because why it is now, as we know that tertiary carbocation is the most stable form of carbocation, so it goes SN1 reaction. Okay, but in this case tertiary carbocation is not stable. Why it is not stable? Because its adjacent carbon have a withdrawing group, that is a more electronegative oxygen atom. It withdraw, it have a partial negative charge, it has a partial positive charge, and both actually in this case both both carbon have a deficiency, electron deficiency. Okay, so that's why this is not a stable carbocation. Okay, this oxygen withdraw towards electron towards and this carbon withdraw electron towards. So this is also, this is not a stable carbocation. Not a stable carbocation. That's why it does not show SN1 reaction. Okay, that's why this halocarbonyl compound does not show reaction. So let's talk about second question. What is our second question? Which is more reactive, propyl chloride or MaCO2Cl? Okay, with the sodium iodide in presence of acetone. So let's understand our problem B. Our question B is, the question is asking like when propyl chloride CH3 CH2 CH2 Cl when react with the sodium iodide in presence of acetone, and another one is CH3CO CH2Cl. It also goes in sodium iodide, react with sodium iodide and in presence of acetone. So in both cases, this reaction is known as Filston reaction. So in both cases, here is a formation of primary carbocation. Okay, formation of primary carbocation. Here is also formation of primary carbocation. Due to primary carbocation, it is not favor SN1 reaction. It favors SN2 reaction. So both favor SN2 reaction. Okay, and in this iodine act as a nucleophile. So this iodine react on this carbon from backside and chlorine remove as a leaving group. So the formation of this compound CH2 CH3 CH2 CH2I. Okay, and in this case same goes to this iodide and as act as a nucleophile and it also attack on this carbon and chlorine remove as a leaving group. So the formation of here is a CH3COCH2I. Okay, and but we have to compare in which case SN2 reaction is occur very fast. So in case of this group X, in case of this group, okay, and this, in both cases here is the electron withdrawing group. Okay, due to this electron withdrawing group, it withdraw electron towards itself and this carbon withdraw electron towards itself, and chlorine already have electronegative atom, so it also withdraw towards it. So what happen here is bond weaken. Okay, due to this bond break very easily, very fast. Okay, so reaction proceed very fast. Okay, so in this case reaction proceed very fast due to this group. Okay, next, what is asking in question C, acetal and ketal are regenerated back to carbonyl compound with hydronium ion but not with hydroxide ion. So acetal and ketal are regenerated back to carbonyl in presence of acid, but in presence of base it does not regenerate to acid. Okay, it does not regenerate to carbonyl. So our C question is, in this question first we have to write what is acetal. This is COR, here is R and OR prime in presence of H plus, it gives this product carbonyl group. Okay, and when it react with in presence of base, there is no reaction occur. Okay, why? Because as we know that OR alkoxide OR minus are in this case here. Okay, This is not remove O minus ion as a leaving group very easily. Okay, so this is not easily removed. Okay, and OR minus is a more basic than OH, so it does not replace this OH group, does not replace this OR minus. Okay, it does not replace OH OR minus group. Okay, so but in case of H plus, what will happen? This OR dash R R and OR. In this case, H plus react on this. What it forms COR positive HR minus and R. Okay, then it forms OR formation of hemiacetal. Okay, here is formation of hemiacetal, and this hemiacetal again react with H plus. Okay, on this oxygen. So what it form? It form RCRO. Okay, this remove, and this OH group attack on this, and this remove as OR minus, and what it form? It form R double bond OH plus R. Okay, so this gives this carbonyl group. Okay, and in case of base, OH OR minus is not easily removed. Why? Because OR minus is more basic than OH. That's why it this acetal form does not back to ketone form. Okay, but in case of acid, it occur very easily. So our next question is, cyclohexane is more reactive than cyclopentanone with HCN. So let's understand D. Question D. Cyclohexane. Okay, so cyclopentanone. Here is cyclopentanone, hydrogen, 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 hydrogen. Okay, in presence of HCN, what it will form? It will form this, here OH, here cyanide, here hydrogen, and here also hydrogen, here also hydrogen, hydrogen. Okay, in this case they are eclipsed, they are eclipsed, that is, it means back to back. Okay, so strain is there, or and hindrance occur, that's why it is not stable. But as in case of cyclohexane, cyclohexanone, here is hydrogen, here is also hydrogen, here is hydrogen, here is hydrogen. So in this case, when it reacts with the hydrogen cyanide, what it will form, okay, here hydrogen, hydrogen, cyanide equatorial position, this is also equatorial position, this one is at axial position, here is OH. So this group and this group and this group, 2 hydrogen and 1 OH, both are staggered to each other. Okay, staggered to each other, that's why it is stable. But in this case, this hydrogen and this hydroxide and this hydrogen, they are eclipsed and hindrance occur more, and that's why they are in strains, and they are not stable. Okay, that's it. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.